we will be looking at binomial theorem. So before that, if you want to expand a plus b squared, you know that the answer is a squared plus 2ab, a squared plus 2ab plus b squared. And if you expand a plus b cubed, it will give you 4 terms, a cubed, 3a squared b, 3ab squared, and b cubed. What we want to do now is do a binomial theorem, which tells you how to expand a plus b power n. And the general term of binomial expansion look like this. A plus b power n is n choose 0, a power n, b power 0, n choose 1, a power n minus 1, b power 1, and n choose 2, a power n minus 2, b choose 2, and so on until n choose n, a power 0, b power n. The pattern is you write down n choose 0, n choose 1, n choose 1, n choose 2 until n choose n. A is the front term. I call A the front term, B the back term. The front term is start with power n. You decrease the power. So it's power n, power n, power n minus 1, power n minus 2, and until power 0. And the back term B, right, you start from B power 0, B power 1, B power 2, until B power n. And if you write any term, you add the power of A and power of B. N plus 0 is n. Here, n minus 1 plus 1 is still n. So you write any term, you add the power of A and B, is always n. And if you write down the general term, it should be n r, A power n minus r, b r. This should be the general term. And then if you sub r is 0, you get n choose 0. Then a power n, b power 0. You sub r as 1, you get n choose 1, a power n minus 1, b power 1, and so on. By the way, n choose r, this is a formula, n factorial over r factorial, n minus r factorial. N factorial I have mentioned to you before is 1 times 2 until n. You can try this out. If you sub n as 2, you should get a squared 2ab b squared. If you sub n as 3, you should get a cubed plus 3a squared b plus 3ab squared plus b cubed. So n choose r is known as a binomial coefficient. It's called a binomial coefficient because it will be the coefficient of the terms in your expansion. And n choose r represents the number of ways to form a group of r people from n people. Let's take the case when it's 5. If there are 5 letters A, B, C, D, E, if you look at 5C2, why choose 2? Means among the 5 letters, you try to choose 2 letters. And if you list out the possible ways, it can be A and B, A and C, A and D, A and E, B and C, B and D, B and E, and so on. And if you count how many ways are there, the answer is 10, which you have listed down. And if you sub n as 5, r is 2 into the formula, you get 10. In a scientific calculator, you can key in 5 choose 2 using this function NCR. It should give you 10. You have this Pascal triangle. Olden days, we don't have a calculator, so I have to work out the binomial coefficient. And we have this famous Pascal triangle, which allows you to write down binomial coefficient. The idea is you start with 1, then 1, 1. The first 2 rows is 1, then 1, 1. And then the third row is 1, 2, 1. Basically, for each row, the first number is 1. And how to get the remaining number? Let me tell you how to get 2 first. 2 is from adding 1 and 1. You add the previous row, the 1 to the left and to the right, you get 2. So if you add 1 and 2, it will give you 3. If you add 2 and 1, it gives you 3. So that's how you get 3, 3. And then the last number is always 1. So the first number, last number is always 1. Okay, so to write down the fifth row, you write down 1. And 1 plus 3 gives you 4. 3 plus 3 gives you 6. 3 and 1 gives you 4. And the last number is always 1. Continuing in this way, you will find that the number, right, this row will give you 5C0, 5C1, 5C2, 5C3, 5C4, 5C5, which agree with what you have from the formula for NC error, or you can check with your calculator. So you can check with calculator. This is 6C0, 6C1, 6C2, 3, 4, 5, 6. So this row is actually 6C error. So it's 6C0 until 6C6. Will give you all these numbers.